Welcome to this exercise on calculating extrema for functions with one variable. Here we have the following function of which we should calculate all extrema. So meaning we first have to determine the possible extrema and then check whether they are actually extrema or just saddle points. Well, to get started, we need the first and second derivative of this function. So we start with the first derivative. We're going to copy the 3 down here, keep it steady, then get the derivative of x to the power of 4. So pull the 4 in front, reduce the exponent by 1. So we have 4x to the power of 3. Well, 3 times 4x power of 3 gives 12x power of 3. Here we do the same thing. We keep the minus 8, take the derivative of x to the power of 3. So it's 3 to the power of 2. So 8 times 3x squared gives 24x squared. Then we do it with the last part. The 18 we keep. We get the derivative of x squared, which is 2x. So minus 18 times 2x gives minus 36. Similarly, we do the same thing for the second derivative. So here keep the 12, get the derivative of x to the power of 3, which was 3x squared, as we've seen before. So 12 times 3x squared is 36x squared. Minus 24 I keep, get the derivative of x squared, which is 2x. So 24 times 2x gives me the minus 48x. And finally, I have 36x. Well, I keep the 36. X, the derivative is 1, so I have the minus 36 here. Well, so much. I am ready to go. I'm well prepared. And I start with finding the potential extrema by using the necessary condition, which says that the first derivative needs to be equal to 0. So I'm going to set it equal to 0. Well, here the highest exponent is 3, so I cannot directly use some kind of formula for this, but I can simplify this a little bit. That is by first dividing the whole equation by 12, making it a bit simpler, but still the problem remains that it's x to the power of 3, but this can easily be fixed because each of my terms includes an x. So I can actually factor out the x. Then it looks like this. And well, if I have an expression like this should be equal to 0, then either the x needs to be 0 for all of it to become 0, or whatever is in the parentheses needs to become 0. So I can say the first possible extremum is at x equal to 0, and the other ones I can find if I set what is in the parentheses equal to 0. So it needs to be this and that, or that, or. Well, this second part is an ideal quadratic equation which I could solve with the PQ formula. P being minus 2, Q being minus 3. So I get my two solutions by taking P and then minus P half minus 2 halves, minus 2 halves, minus gives plus, 2 halves is 1. So the 1 here. Then plus minus for the two options, square root of P half, so minus 1 squared, 1 gives those two 1s, minus Q, minus 3 gives plus 3. So I have square root of 1 plus 3, so square root of 4, and it is 2. So the first solution is 1 plus 2, and the second solution is 1 minus 2. So giving me here another potential extrema, 3 and minus 1. So I have 3 potential extrema in total, 0, 3, and 1. Well, up to this point, they're just potential extrema. So in my next step, I need to use the sufficient condition to check whether they are actually extrema and what kind of extrema they are. So I start with the smallest one, -1, insert this in the second derivative, calculate the expression and get as a result 48. 48 is a positive value, and if the second derivative turns out to be positive, then I have a minimum. Then I take the next largest value, 0, insert this, and I get as a result -36. This is negative, and if the result is negative, this is an indicator that I have a maximum. Finally, the largest value of 3, if I insert this, calculate the values, I get an end result of 144, which again is positive, indicating a minimum. And well, this does not come as a big surprise, because I originally had a function, a polynomial function of degree 4. This polynomial function usually has either 3, or if I do not have any extremum but saddle points or something like this, then maybe 2. But if I only have extrema, I have 3 or 1 extrema. So here I see I have 3 potential ones, so this is usually an indicator of 3 extrema, and they're changing, so it's minimum, maximum, minimum. Could alternatively be maximum, minimum, maximum, but never something like minimum, minimum, minimum. Well, with those concluding remarks, I'm finally at the end of this exercise, so I say goodbye and see you next time.